dear learners, welcome to today's MCQ series on gravitation. So, with your permission, I want to start MCQ series. Thank you. So, here is the first question: a body weight W on the surface on Earth's surface. What will be its new weight if the distance from the center of Earth is doubles? So, let us consider this is Earth and we have one object, there is one object, and weight of that object is W. This object pulled some more distance, that is from here to here and here to here. From here it will pull some more, that means that distance is double. The distance from the center of the earth is double. So first initially it was here, later it dragged to this side, so that means from the center the distance is what? It is double. The distance is double. Then what is the new weight? This is the question. Clear? So first of all, let me go for at the surface of the earth. We will consider what we will consider. You can consider the formula, that is W equal to G M M by R square. So this is the formula for the weight. As you know, weight equal to mg. Clear? Okay, no problem. W equal what? W equal to mg. And what is g? G is nothing but gm by r square. We have a relation. Is it right? Gravity relation. So now that is gm m by r square. And here in the question clearly mentioned that one distance is double, so that gmm, what is double? R, so r square. Upon simplification, gmm by 4r square. Now check here, 4r square, so what is 1 by 4 you can taken out, then gmm by r square. So gmm by r square is what? Gmm by r square is initial weight. Am I right? It is about initial weight. So 1 by 4 of initial weight. So the initial weight is 1 W and the final weight becomes W by 4. That means that initial weight is reduced by 4 times. Initial weight reduced by 4 times. Am I right? Okay, very good. So second one, two masses separated by distance are attracted with force F if both masses are double and the distance is half. What is the new force? So let us consider the question is two masses separated by certain distance and the distance is what? R, and the force is what? F. Now the both masses are double, and distance is half. What is a new force? First of all, you should consider, let us consider this is a body A and body B. The body A and body B masses are separated. Let us consider this is M mass, this is M mass. Is it clear? Okay, I will explain. Apart from this, I can go with another explanation. Here I can see this explanation. Okay, now they are separated by R. We know very well gravitation formula. What is that one? F equal to m1 m2 by r square. Clear? So now mass is double. Masses are double. So means this is 2m, this is 2m. Clear? Otherwise you can take this is m1, this is also m2, and distance is what? Distance is half, that means r by 2. Now upon simplification we will get 2 to the 4 m1 m2 by r square by 2. Upon simplification sorry, not 1 by 2, 1 by 2, that is 1 by 4. So 4 4 ja, so that 16 m1 m2 by r square. So new force will be 16 times to the origin, means initial force. Clear? Understood? Okay, you can see here setup. One is the initial, means length is 1 meter and mass is 1 kg later. So that is about F equal G m1 m2. But here which what we done, we changed this is 2 2 and this is r by 2. Upon that you got that one, F equal to 16, F dash equal to 16 F. Check the answer explanation only. So two spheres attract with the force F. What is the new force if the mass of both the sphere is double? So here question is what force. The question again asking about force. So what is the formula? F equal to G m1 m2 by r square. So they are initially separated by r distance. So that F equal to G m1 m2 by r square. Clear? Now what we changed? Mass of both sphere is double. So this is 2m1, this is 2m2. Now what is the new force we need to find? Clear? The new force is what? So let's consider, replace this values. F equal G, F dash equal G 2 m1 m2 by r. There is no change in r distance. So upon that you will get 2 to the 4, that is about 4F. So the new force will be 4 times of the initial force if you double the mass. Coming to next one, two identical solid pairs of mass m and radius are in contact. What is the gravitational force between them? Gravitational force between them. So here is the answer. That is about, first of all, two identical solid pairs of mass m. So there are, this is a, sorry, this is one of the solid sphere, this is another solid sphere, both are having mass m. Clear? And radius r little space is there, that is about the radius r in contact. Gravitational force. So gravitational force formula is what, beta? So that is F equal to G m1 m2 by r square. Clear? Our radius is r, mass is m, and now from here to here smaller, here to here smaller. So the center of the radius is what? Center, that is about the r equal to 2r. When they are contacted, that center of the radius will be 2r. Now your force formula is what? F equal G m1 m2 by r square. So now it will be 2r. So what is happening? That is G, they are identical masses. So this is m, this is m. So that is Gm square by, this is 2r. So that is the reason the new force will be half of the, sorry, 1 by 4th of the original force. Is it right? Yes or no? So that is about 1 by 4th. Clear? So your answer is option B. Sorry, option A. Sorry, here. Okay, clear? Okay, now a satellite of mass m is at a height equal to the Earth's surface, Earth radius, that is h equal to r. What is its gravitational potential energy? So now gravitational potential energy formula, what is that? That is U equal to minus G mm by r. This is gravitational potential formula, minus G mm by r. Now it is clearly mentioned the satellite of mass m is at height equal to the Earth radius. So height is equal to Earth radius. That formula is r equal to r plus h. It is clearly mentioned h equal to r. So that r equal to r plus r, which is nothing but 2r. So clear? Now as we know, at the surface the weight is w equal to mg. At the height the new distance is r plus r, which is about 2r. Our formula is for the gravitational potential, and that is U equal to minus G mm by r. Clear? Now replace here. So this is U. and weight equal to gmm by r square. So you want only this one, you want gravitational potential, so you go with this formula, so no need this one. So u dash equal gmm, what is r equal to r, so that your answer is u equal to minus gmm by 2r. What is the binding energy of a satellite in circular orbit of radius 2r? So radius r only. So the satellite is revolving around the earth. From here to here the distance is r. So circular radius is r, and here energy component, as we know, there is potential energy and kinetic energy. Potential energy we shown just now, that is minus gmm by r. Kinetic energy gmm by 2r. So it is a question is, what is binding energy? Binding energy is nothing but bound energy of kinetic plus potential. So here, to maintain a stable orbital motion, the energy is conserved, and that is equal to sum of potential and kinetic energy. Clear? So here, after placing these two things, then you will get, that is binding energy is equal to kinetic energy. So that is the reason it is revolving. So you can take that one, the kinetic energy. See, what is binding energy? Question is what? Ke. What is Ke? Ke equal gmm by 2r, and here minus gmm by 2r. After simplification, what you will get? You will get g. See, that binding energy is equal to negative of kinetic energy. What is that one? Negative of kinetic energy. So that you can take that one. Your answer is what? gmm by, so why it is binding? Okay, sorry, question is about the binding energy, so you can take that one, gmm by 2r. So that is about this one. Okay, next one, what is the gravitational potential at distance r from the point M? So here this is the mass and this is center, and now what is asking? They're asking about the gravitational potential. Gravitational potential is equal to gm by r. That's a simple issue. So that is about potential energy is nothing but gm by r. This is about potential energy. This is formula for potential energy, but here asking that only potential. So the potential formula is V equal to minus gm by r. What is that? V equal to minus gm by r. V equal to minus gm by r. This is about the potential. This is about potential energy. Minus gm by r is potential energy, minus gm by r is just potential, and negative is indicating that is it is in bounding system. The energy is bound in a system, particular system. Earth attract a satellite with a force F1. The satellite attract Earth with a force F2. Which statement is true? You already know, apple whenever falling on the earth, similar way, earth also moves toward the apple, but we can't see this one because of this is a microscopic character. So here, when the size of the earth is very high when compared to the apple, so that is the reason we are unable to view this concept. Now here the question is that earth attract a satellite with a force F1. Earth attract a satellite, so here is the satellite is there, and this satellite is attracted by force F1. Similarly, the satellite is also attract earth with the force F2. The satellite attracts earth with the force F2. So as per Newton's third law, F1 is equal to F2. So the force exerted by the satellite is gmm by r square. In a similar way, the force exerted by the earth and the satellite is gmm by r square. Both are same. So here uh, both the force attracted the satellite, earth attracted the satellite, both are same. That is F1 equal to F2. What is the gravitational potential V at a distance r? Just now we discussed that is about the minus gm by r. Repeated question. Okay, now at what depth d below the surface does acceleration due to gravity becomes 1 by 2 its surface value g by 2. So here at what depth d below the surface does acceleration due to gravity becomes 1 by 2 its surface value. So here as we know g for at depth, that is 1 minus d by r. What is that? 1 minus d by r. This is for the depth formula. Now when g becomes 1 by 2, so depth and surface, you can consider here g depth equal to g surface of 1 minus d by r. So that g depth by g surface equal to 1 minus d by r. So here it clearly mentioned, what mentioned, the below the surface the acceleration due to gravity becomes 1 by 2. Its surface value is what? The surface value is, it clearly mentioned, that is half, means g by 2. See g depth, so 1 minus this is distance is what? 2. So you can take, sorry, just okay, no problem, I will do here g depth by g surface equal to, our formula is what? 1 minus d by r. Clear? Now d by r equal to, you send this term this side, that is about 1 minus, send this side, send this one. So d by r equal to 1 plus, so sorry, this is 1 minus gd by gr. So what is gd? Gd is nothing but 1 and gr is nothing but 2. So upon simplification you will get 2 minus 1 by 2, that is 1 by 2 d by r, and finally d equal to r by 2. You go with the formulas only. The acceleration due to gravity g at height is 1 by 4. Its value on Earth's surface g. Find h in terms of Earth radius. So first of all, the g value, g equal gm by r square. At height, as we know, g dash gm by r plus h whole square. So that we have a relation g height equal to g surface of r by r plus h whole square. Therefore, gh by g surface equal to r by r plus h squaring. Clear? So now gh by g surface, how much they given? That is about the acceleration due to gravity, the height is 1 by 4. So that is about, this value is what it is clearly mentioned, that one. Acceleration due to gravity is what? The ratio is about 1 by 4. Clear? And 1 by 4, how we will get this is 2 plus, okay, wait. G dash by g, the acceleration due to gravity g at a height h is 1 by 4. Height h is 1 by 4. We need to find what? acceleration. Sorry, we need to find height. Okay, clear. So that, okay, it is clear dimension, no problem. So, okay, g dash by g equal to r by r plus h whole square. 1 by 4 tends to radius, so that we can take here r plus h equal to 2r, then h equal to r, h equal what beta r only na, so 1 by 2 1, okay, this is about 1 by 4 na, okay, it clearly mentioned 1 by 4, so r equal to 1 by 4, so 2r equal to r plus h, so you can go for the same way, it is clearly mentioned. These formulas we should follow. Okay, next, planet X has twice the mass and twice the radius of Earth. What is G on planet X compared to G on Earth? So first let us consider G on Earth, that is about Gm by r square. Gm by r square. G on X planet is, the planet X had twice the mass, okay, it is mass double. This is mass of Earth, this is planet X, which is nothing but double mass. Okay, G of 2me, double of the Earth mass, so G of 2me, and radius also twice, so that is 2re square. Now simplify, then 2gme by 4r square e. What is 2 by 4 take out, then gme by r square. Now 2 by 4 is nothing but 1 by 2. So this is gme by r square is nothing but g. So 1 by 2 g. Clear? 1 by 2 g. That means g by 2. Here clearly mentioned planet M, Earth mass is me, planet X is 2me, radius is re, here it is 2re. Okay, this is not here. This is okay, clear. Then we go for the next one. A satellite is in a circular orbit of radius r, which is r equal to 4r. The height is 3r. With the velocity naught, if the doubles to r dash equal to 8r, what is its new orbital velocity? Orbital velocity is how much? 7.2 km per second. Is it right? So here, first of all, initial orbital mass, that is about the clearly given for r. Initial velocity formula we know very well. V naught equal to, what is the formula? Root g r, g equal to gm by r square into r. So finally you will get, that is about gm by r. So v naught equal to gm by r, and it is clearly mentioned, what mentioned, r equal to 4r, so that v naught equal to root gm by 4r. Clear? Now what we need to find, that is with velocity, if doubles, sorry, it is doubles to r dash, that is initially it is 4r, now double means what? 8r only na, so gm by r dash, initially it is 4, now it double means 8, so root gm by 8r. So upon simplification you will get that new orbital velocity. What is the question? Sorry, okay, orbital velocity, no? So that is about v naught equal to 1 by root 2 root gm by 4r, gm by 4r. So there is answer. And this is, as we know, relation between escape velocity and orbital velocity. V equal to 2 V naught. Clear? So now V naught, how much we got here? We got is here 1 by root 2 root of Gm by 4R. Now we replace here. So here your answer is 1 by root 2 under root of Gm by 4R. So under root of Gm by 4R is what? That is our question. Okay, there is one. Okay, there is some mistake in the answer. Let me clear one thing. Okay, first you come to here. This is about the orbital velocity, new orbital velocity. So your options are what? In terms of the escape velocity, they are asking, I think so. VE equal to root 2GR. Clear? So, sorry, root V naught. So you keep, what is V naught we got here? 1 by root 2, sorry, 1 by root 2 root Gm by 4R. How it is possible? Escape velocity 2 times. Sorry, okay, it should be 2 times, but here wrong assumption they given to you. To V naught. Okay, wait. I have to match with the answer. So here you can take. So this is about Gm by eta. This how can we write here? Thus we can go with the 1 by root 2 into Gm by 4R. Okay, clear. Then our relation is what? V equal to root 2 V naught. Clear? So root 2 V naught is what? Okay, this is options. Actually V equal to root 2 V naught. This is the condition. Double of the orbital velocity. So here this is a little bit tricky, so I go with this option only. You change any one of the option, that is about the root Gm, new orbital velocity is root Gm by eta. Okay, I don't want to waste time. I have to go with the other questions. According to Kepler third law, the square of the orbital period T of planet is proportional to. So that is according to Kepler first law, second law, third law. Kepler first law is about the elliptical orbit. Kepler second law is about the dA by dt is nothing but constant. That means planet covers equal area in equal interval of time. That means planet spheres equal area in equal interval of time. So next one, Kepler third law, that is about the time period of the square of the orbital period is proportional to the semi-major cube of the semi-major axis. Clear? So that is about, then we will have, that is t square is proportional to a cube or r cube. So a satellite of Earth, okay, a satellite orbits the Earth at a distance r with a time period t. If the orbital distance increases to 4r, what will be its new time period? What will be its new time period? So here, so we go for the concept that is about time period formula, t square is proportional to r cube. So a satellite orbit around the distance around at the distance r with the time period. If that orbital distance increases 4 times, so t1 by t2 by t1 equal to r2 by r1 cube. So what is new time period? So here what is r2? R2 is nothing but if the orbital distance increases to 4r, okay, 4r. So 4r and r. Initial one is what? R. So and first time period is what? T. So T2 or T new equal to T 4 into 4 4 4 4 16 16 64 by r cube r cube. So that this is about squaring. Then T new equal to under root of 16 is 8 and T. So your answer is 8. Escape velocity V is independent of the projections of angle or mass. If the mass is double, V changes by factor. So it clearly mentioned escape velocity depends on what? It is escape velocity depends on only R, not mass. Your question is mass double. So escape velocity V equal to root 2 V naught 11.2 km per second for the earth. So here no mass in equation, no change factor. So your answer is remain unchanged. What is the new gravitational potential at the distance r from its mass m? So I think so it is repeated. Gravitational potential minus gm by r. Okay, next, at what depth d below the surface does acceleration due to gravity becomes 1 by 2 its surface value g by 2. Even though it was also done, sorry, it is repeated. Okay, next one, earth surface in terms of the earth radius. I think so it is also repeated. Sorry for sorry. Okay, now two identical solid spheres, they are two masses separated by distance are attracted with the force F if both masses are double and the distance is half. What is the new force? So first let us consider F equal to m1 m2 by r square. Formula: two masses separated by distance r with the force F if the both masses are double. So that is 2 m1, sorry, this is 2 m1, this is 2 m2. Now what about distance? Distance is half, r by 2. Now both the masses are doubled. Doubled means 2 to the 4. 4 m1 m2. Distance is half, r square by 4. So that is about 4 into 4, that is 16f. So mass double, distance is half, that means it is 16 times. Next, two spheres attract with the force F. What is the new force if the mass of both the sphere is double? So there is no change in the r. So F is proportional to m1 m2 by r square, and masses m1 is changed to 2m1, m2 is 2m2. There is no change in the distance. So g 2m1 m2 by r square, which is nothing but, upon simplification you will get 4f. There will be 4 times change. Which statement about the universal gravity constant and action due to gravity is true? See, g is constant everywhere. This g is changing from planet to planet. It is 6.6 into 10 to the power of minus 11 Newton meter square per kg square. If you take this is on earth, it is 9.8 meter per second square. On moon 1.67 meter per second square. So the value will be changing from planet to planet or celestial body to celestial body, whereas G is remain constant. G is a fundamental constant. G, capital G. Small g depends on location. That means mass, radius, height. Okay, next a body weight. Okay, this is also complete, right? Okay, and finally another question, mixing question is related to the wave. So, a transfer wave travels on a rope with a wavelength lambda. If the tension is quadrupole, that means four tension, keeping the frequency constant. What is the new wavelength? So here, first of all, what is transfer wave? The wave which move perpendicular to the propagation, and that is about the transfer wave. Is it right? Which moves in perpendicular manner. So that is about the transfer wave. Here is a question given. First of all, transfer wave travels on a rope with a wavelength lambda. With a wavelength lambda. If the tension is quadrupole, T is quadrupole. That means 4 times. Okay, now we have a formula. What is V equal to nu lambda? You can see the figures also. Let me go with it. V equal to nu lambda. Lambda equal to V by nu. First of all, source frequency is here, and this is the rope, and the rope undergoes the tension, and there is some velocity in the rope, that is about the V, and wavelength is lambda. So we know the formula, that is velocity tension mu, that is about the V equal to under root of T by mu, and this is the formula for the speed in a transfer wave. Now the tension is quadrupole, the tension becomes 4 times. So what is the new? Okay, what about the new velocity? The tension is so the frequencies remain constant. Frequency, there is no change in the frequency. So now the new velocity becomes what? So when we substitute the so that is a formula. So here V equal to under root of T by mu. Now T is what? 4 times. Means V is proportional to, as a formula, V is proportional to tension. V is proportional to tension. So V dash equal to new velocity, that is 4T by mu, and now upon simplification you will get T by means root 4 means what? 2 only, na? So 2 into root T by mu, that means velocity is double to initial velocity. Now the wavelength formula is what? V equal to V dash equal to frequency constant, so V dash equal to nu lambda dash. Lambda dash equal to V dash by nu. So what is V dash? This is so 2V by F. 2V by F. F is nothing but what? Frequency. So 2 of V by F. V by F means what again? It's lambda. So your answer is okay, clear. I think so. You okay? I will go one second, no problem. Generally, V equal to root T by mu. Clear. So now the question is that tension is 4 times. So V equal to 4T by mu. So this is 2 root T by mu. Am I right? T by mu is what? V only, na? So V dash equal to, this is V dash. V dash equal to 2V. Clear? So now your formula is V dash equal to 2V. You got it, same thing. Now wavelength, new wavelength. V dash equal to nu lambda dash. Lambda dash equal to V by nu, V dash by nu. This is common. So V dash is how much? Just we got V dash equal to what we got? What we got? V dash equal to 2V by nu. So 2 of V by nu. V by nu అంటే ఏంటిది మళ్ళీ? V by nu is nothing but lambda. So that 2 lambda. And the last one, that's about the spring mass system oscillate with the period T. If the spring constant K is double, what will be the new time period? So here let us consider the spring mass system, and the formula for that one is T equal to 2 pi root m by k. Now it is parameter. What is spring mass system? Accelerate with the period t. If the spring constant k w, k becomes 2k and m is constant too. Then your formula is t equal to 2 pi root m by k. Clear? Now just go to the formula, that is about t equal to 2 pi root m by k, and the new time period t dash equal to 2 pi root m by k. Now t dash equal to 2 pi root m, there is no change in the m, is it right? So k will be 2k. T equal to 2 pi root m by k. Now see, upon simplification, what you will get? T dash equal to T of 1 by root 2. T of 1 by root 2. Clear? So T dash equal to T by root 2. Okay, thank you. Okay, no problem there. Sorry, there is some errors also there in the slide, but please be. I tried to provide a innovative way. That is the reason I done this one. But during the procedure, some. But the visuals are so attractive. That is the reason I was not changing the that few of the errors, because if I change means you may lose the visuals. So to provide the attractive visual, I done this creative manner. So during this process, some technical issues were happened, and sorry for that one. Next time I will focus on the things. Okay, thank you.